Good morning everyone. I'm Dr. Deborah of ECE department from Dr. NGR University. Today I'm going to talk about error codes, detection and correction techniques. Now when we talk about errors, now what are errors first of all? Errors are some unwanted information that gets added on to our original data. So now where does the errors occur? Errors do not occur at the transmitter side. Transmitter being the place where we send the data. Errors usually occur in the channel. Now, when these errors occur in the channel and when they get transmitted, the receiver would be getting the data that is corrected. Now, these errors have to be detected efficiently by the receiver and the detected error should be corrected. There are various methods, algorithms and codes that are used for error detection and correction. So, errors are happening in the channel. And these channel errors are also called as noise. Now we have channel encoder in the transmitter side. Which helps the receiver to detect errors and to correct them. Now what is the function of the channel encoder? Channel encoder adds some extra bits called redundant bits which helps the receiver to detect the errors and correct them. These extra bits are called as redundant bits. For example, we have message bit and then we have encoded data. Now, encoded data bits are represented with n bits, which means if the message bit has k bits and the encoded data has n bits, so parity bits is n minus k. So P parity bits is n minus k, which means the encoded data has some extra bits which is being added by the encoder, channel encoder. The original message bit has k number of bits. Now if we subtract the encoded data from the original message bits, we get the parity bits. Now, so this is how encoding happens. Now the different types of error codes are linear block codes, cyclic codes, Hamming codes, convolution codes. We will discuss about each of these different types of codes in detail in the coming session. Now, data is being transmitted and how it is being received. Let us consider Let us consider the message signal is given to a channel encoder the function of the channel encoder is to add some extra redundant bits. This is a short block diagram of how data is being transmitted and received. So, here our message signal consists of k bits. This is given to the channel encoder. Now, channel encoder, as I already told, it adds some extra bits, which we call it as parity bits, which will be later on used by the receiver for error correction and detection. So, the extra bits added by the channel encoder, let us call it n. Now, n minus k will give us the extra bits, that is how many bits were added by the channel encoder, which we call it as parity bits. Then we have a modulator. There are different types of modulation techniques that we have already discussed in the previous units. Now, the modulator makes the carrier to be modulated or superimposed on the message signal, then it is being transmitted in the channel. So, this is the channel where noise gets added to our original message. Then the receiver part has a demodulator, which will, demodulator's function is removing the carrier from the message signal. The channel decoder then detects any errors and then helps in correction process, and then we get the original message back, which has k number of bits. So, the channel encoder is a protector of the signals or the data. Now, how many bits were added? Can be found from n minus k. So, total number of bits from the channel encoder is n. Okay. Now, there are two types of error detection technique. One, the receiver informs the transmitter to resend the data. So one method is the receiver informs that an error has happened and it asks the transmitter to resend the data. Now when this method is followed, it causes delay. Whereas the second technique, where the receiver does error correction with the help of different types of error detection and correction code techniques, this makes a lot of difference in data communication. Okay, so now we will see the different types of error codes. Before we discuss about the different types of codes, we will see some terminologies that are essential for our understanding. Code length. What is code length? It is the total number of bits in an encoded signal, which we represented by the letter N. Code efficiency. Code efficiency is the ratio of the encoded bits by the original message bits. Eta is the letter which is representing code efficiency. Code efficiency value can range between 0 and 1. Code weight. So code weight is the total number of non-zero bits in a code. Let's take for example the code 110111. So the total number of non-zero bits in a code. Here we have only one 0 bit and the rest of the bits are ones. So here the code weight is 5. For example, let us consider another code. Here, the weight, can you tell me what is the weight of this code? It is 3. Yes. Okay. Now, we all know about parity. Parity, as we already discussed, parity is the number of extra bits added by the channel encoder. Now in parity there are two different types. We have even parity and odd parity. If the number of ones in the encoded bit is even, we call it as even parity, and if the number of ones in the encoded bit is odd, we call it as odd parity. This is used for error detection and correction purpose. Okay, now let us discuss about the error detection codes. First, I am going to discuss about Hamming code. Now, when we talk about Hamming code, the first topic is going to be about weight of the Hamming code. Weight of the Hamming code. This weight of the Hamming code is obtained by doing modulo 2 addition of two different codes. Let us consider code C1 and another code C2. When we do modulo 2 addition of these two codes, we can find the weight of the Hamming code. For example, let us consider code 1 as 11000101 and code 2 as 01100101. Now, to find the weight of this Hamming code, we have to do modulo 2 addition. The symbol is modulo 2 addition. Now, before we go into the modulo 2 addition, I just want to brief you about the modulo 2 addition process. This is the truth table for modulo 2 addition. If we have two input bits as 0 or 1, we get the output as 1. If either of the bits are 1, then the output is 0. Now, after understanding the truth table for modulo 2 addition, now we will do the modulo 2 addition of codes C1 and C2. Okay, so 1, 0 is 0, 1, 1 is 1, 0, 1 is 0, 0, 0 is 1, 1, 1 is 1, 0, 0 is 1, 1, 1 is 1. Now, as I already told in the previous topic, how do we find the weight of a code? Weight of the code is the total number of non-zero bits. So here the total number of non-zero bits is 5. So, weight of this code is 5. Okay. Now, let us go to the next topic. Hamming vector. So, Hamming vector is a combination. If we consider 3 bits in our data, so the combination of zeros and ones form 7 different. It forms 8 different combinations of zeros and ones. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now these codes are called as Hamming vector. Next is Hamming sphere. Now let us consider we transmit bits 000 through a channel, and if error occurs. Now when we plot the errors on a graph, this error plot is called as the Hamming sphere because the graph represents a sphere. Now whenever we plot any errors on a graph, it represents a sphere. So we call this as a Hamming sphere. The next one is Hamming bound. Hamming bound. Hamming bound is given by 2 to the power n minus k should be greater than or equal to summation I is equal to 0 to t nci. Now this Hamming bound helps us to find out the number of errors happen. Okay, so we will do a problem based on this Hamming bound. So that will be able to help you understand better. Now okay, a 7,4 linear block code has t is equal to 1. Find whether it is a Hamming code or not. Now, this 7 represents n, this 4 represents k. N means it is the encoded bits, k means the original message bits. So, n is equal to 7, k is equal to 4. Now, we will substitute this in this equation. 2 to the power 7 minus 4 should be greater than or equal to summation I is equal to 0. T is given as 1, so we put 1. N is 7, C, I. So 2 to the power 3 should be greater than or equal to, I am expanding the summation, so 7C0 plus 7C1. Now 2 to the power 3 we know it is 8, should be greater than or equal to 7C0 is 1 plus 7. So 8 is greater than or equal to 8. So this 7,4 linear block code is a Hamming code. Okay. So since this condition is satisfied, we call this code as a Hamming code. We will continue more on solving the problems of Hamming codes in the next session. Thank you.